Okay, so we're going to have a go at a past paper question from June 2016, C4 paper, question number 6, part 2. And this is a very typical A-level question where they give you a difficult integration to do, but they guide you along, and in the end they make you find the final answer. So we'll do this together. So part A, use the substitution x equals 4 sine squared theta to show that this equals this, where lambda is a constant to be determined. The question is very kind here. You look at this and it looks tricky and difficult, but the question is very kind that they give you which substitution to use. So we're going to use the hint that is provided to us. So x equals 4 sine squared theta. And to substitute this in here, we know that we know our x, but we have to change our limits, and we have to know what our dx is in terms of theta. So I'm going to find d theta, dx first in terms of d theta. So to find dx, I'm going to differentiate this function in terms of theta to get dy by dx equals, so 2 comes down to give us 8 sine theta, and the derivative of sine theta, which is cos theta. And this all gives us dx equaling 8 sine theta cos theta d theta. We have to change our limits as well, so we're going to start with the lower limit when x equals 0, 4 sine squared theta equals 0, and this gives us theta equals 0. And the upper limit when x equals 3, 4 sine squared theta equals 3. So sine theta equals root 3 over 2. And theta, we know that when we're doing integration, we only deal with radians, not degrees. So theta is going to equal pi over 3. So we got to dx. We know our limits, so we can plug everything in the left-hand side of the equation to get, so the limits we got from 0 to pi over 3, and x, we know we're given that it's 4 sine squared theta all over 4 minus 4 sine squared theta. Dx, we found out that it's 8 sine theta cos theta d theta. And by looking at this, I automatically want to cancel my 4 and take 8 out to get, well, just to make it simple, square root of 1, no, not 1, sine squared theta over 1 minus sine squared theta, sine theta cos theta d theta. And I look at this, 1 minus sine squared theta, and by this time we have to be able to spot that this equals cosine squared theta, because sine squared plus cos squared equals 1. So I'm going to change that to cos squared theta. And we can take the square root out because the top and bottom are both squared. And yay, the causes cancel. And we have two signs. So we get sine squared theta d theta. And as you can see, this is exactly in the form that the question asks you to find. And we have our constant 8, which is equivalent to lambda here. So we have determined the value of lambda, and that's it.